Okay, let's look at question number 8 of the applied paper. So this is friction and equilibrium question. Right? So uniform rod AB of weight W and length 2A rests in equilibrium with A in contact with rough plane. So this plane is rough, inclined at an alpha to the horizontal, and B again smooth. This plane is smooth, or this wall is smooth. The rod is perpendicular to the plane as shown in the diagram. If the coefficient of friction between rod and rough plane is mu, we have to show mu is greater than or equal to that. Right. So what do we know? Mu is greater than or equal to F over R. No? So we need to find friction and normal reaction. Right. So then we can show this. Right. So first let's draw a diagram. Right. Then mark everything. So you can also do it here. I will just draw a big diagram. When you are doing the problem, just mark the forces on the given diagram. So we have this, right, and this is smooth, this is rough. Right. Then let's start marking the forces. So this is smooth now, so only the normal reaction is there. Let's say R1 or RB. Then at the midpoint of this rod you have weight W. Then this length is A, this length is A. Then you have normal reaction for this rod that goes, because this is perpendicular, it's just going through the rod itself. So we'll mark it as RA. Right, now friction should be marked in which direction? So this will try to go in which direction? This is in equilibrium, so it will normally try to slide down. If its tendency would to slide down, so then the friction will be trying to stop in that. So friction should be marked up along the plane, so like that. Right. So then, right, so yes, so friction should be against the tendency to move. So it's this rod will be trying to slide down, so we are trying to prevent it. So friction should be up. Right, everything is marked. Now angles. Right, angle. This is alpha. Then this is alpha. Then this is 90 minus alpha, so this is also alpha. And let me draw the vertical line also. Then alpha, 90 minus alpha, this is alpha. Right, so everything is marked. Now let's see, we need to find friction and normal reaction to get this inequality. So what's the easiest way to find friction? You can take moments about this point, then you don't need to consider what the two reactions. No, both of them go through that point. So let's take moments about B anti-clockwise direction, and because this is in equilibrium, all of them together should be equal to 0. So F is anti-clockwise, no? This is rotating anti-clockwise, and the perpendicular distance is 2a, no? This line, 2a into F, or F into 2a, that is positive. Then the weight is going clockwise, so then it is minus W. What is the distance, perpendicular distance from point B, right? So that is this length, no? We need this length. Let me mark it as what, H. Then what is H? This length is A, right? This red part is A, no? So then we can use this right angle triangle, A sine alpha, right? H is A sine alpha. So A sine alpha is this length. So then you have to multiply W by that. A sine alpha, this is equal to 0. Then cancel what? Common term A. So then you have friction. Friction is what? 2F is equal to W over sine alpha. Then friction is equal to W over 2 sine alpha, right? So friction done. Let's mark it as 1. Then you have to find normal reaction. This one, RA. So for that, moments won't work. If we try to take moments, we have to find normal RB also, no? So that won't work. Best thing to do is this is in equilibrium, no? So we'll consider vertical components. Then I don't need to worry about RB, no? So vertical component should be equal to 0, no? So to avoid doing anything with RB, I am just going to do vertical components. So because this is in equilibrium, vertical components, let's take upward direction. Sum of the vertical components should be equal to positive. So we'll take up as positive. Then RA cos alpha, RA cos alpha, R into this direction. So that is positive. RA cos alpha positive. F into this direction, F sine alpha, F sine alpha, that is also positive because upward direction. Then RB we don't need to worry. Then minus W equals 0. So now simplify and get RA cos alpha equals W minus F sine alpha. Then F we found, so substitute from here this one. What is F? W over 2 sine alpha again, no? So then you will get W minus, right, let me write it in the next page. RA cos alpha W minus W over 2 sine squared alpha, right? That is what we have now. Yes. Then let's find RA. Divide by cos alpha, everything. So you get W over cos alpha minus W over 2 cos alpha sine squared alpha in the numerator. Let's take the common denominator, which is what? 2 cos alpha 2W minus W sine squared alpha. Take the W out, so 2 minus sine squared alpha 2 cos alpha, that is RA. So mark it as 2. Then mu is what? Mu is greater than or equal to f over r. So f is from 1, you substitute from 1 and 2 into this equation. So what will you get? Mu is greater than equal to f is what? W over 2 sine alpha. That is from first equation. Then substitute from the second one r, which is w 2 times 2 minus sine squared alpha over 2 cos alpha. Right. Then you can cancel. W over 2 cancels. Cos alpha goes up, no? This one, you flip it, so you get sine alpha, cos alpha in the numerator over 2 minus sine squared alpha. That is what we want to show. Mu is greater than or equal to sine alpha cos alpha over 2 minus sine squared alpha. Right. So this one, it's just taking moments and uh, taking the y components, sum of the y components equal to 0 to find f and r. That's it. Right. Okay. Then we'll see the next question.